thank you very much. I'm Thomas Haustein from Fraunhofer. Fraunhofer is Europe's largest research organization. We are doing applied research. And to give you some background, I worked, I don't know, 15 years. I started in industry with Siemens, which became Nokia Siemens Networks, when I worked with Sari, when she was already in standards and I was in R&D. And then I moved back into research. And since we do applied research, we always try to keep close collaboration with industry, so we do meaningful research. And my talk is about international research collaboration, and I believe that's really the key to make 6G sustainable in the sense of that the outcome is something which is good for society and in general. I mean, we heard a lot about the components and what the ingredients of 6G can be. I think it sounded like we all agree on what will be in it. I disagree. I have a big sense of that there is a lot of unclarity, uncertainty, and we will see if in 2-3 years we sit together and starting 6G standardization. But what we definitely know is that we have tools to handle computation, we have tools for sensing and data, and we have the communication system. And this, to bring all together, gives us the opportunity to have a new dimension, and that might be the foundation for 6G. And I mean, we have a lot on different key drivers behind 6G, new applications. We heard about these XR applications, and then this integrated communication and sensing is really probably one of the big drivers which will break some barriers which we had before. Then the proliferation of intelligence. AI was on many, many slides, so I don't go into that too much. And what I've seen when attending standards, we give it a try to understand where we need standardization for AI, and yeah, it's a beginning, and I'm very happy to see that, and I think, so get it really into the system will take us far into 6G. And then we have, I mean, big drivers from society and also new business opportunities. I mean, we have worldwide sustainability goals. I mean, the network has to be more energy efficient, and then the increased role of data for new business models is important, and things are connected, and that also has concerns on privacy, so having privacy embedded in the system is something which will drive towards new solutions for 6G. And I mean, we will have new dimensions how we can handle this, and I'm happy that I heard a lot of talks on really going to even higher number of antennas combined with higher frequency. And as a physicist, I'm really happy to see that now also the engineers are starting to go for keeping the panel size constant, putting more antennas to really get away from dependency of path loss depending on the frequency, because I mean in free space there is no path loss difference if you double the frequency, it's just the size of the sphere where you collect the energy. And so far with small antennas and single antennas, we had the dependency. If we stay with bigger panels, we get rid of this dependency, and then we can also achieve similar throughput with better beamforming and same energy connection over larger distance. I mean, going to a higher frequency, I mean, Jehoon was already talking about sub-terahertz. I will have a few slides on this as well. But then there's another dimension. It's really, I mean, going into the third dimension, bringing base stations up there, or having these satellites operating as base stations, and that really fills the gap of where we don't have networks or will not deploy networks on the ground because it's inefficient for the sparse user distribution. And to really look into all that, then we really have to look what is the road to 6G. And I mean, COVID-19 really showed us that communication systems help us to enable things we didn't have before. I mean, the whole working and interworking landscapes changed a lot. We've seen that. And I mean, during the pandemic, we started 5G Advanced. And I mean, a lot of 6G programs were started, kicked off in different regions of the world, mostly independently. And I mean, just to mention it, we've seen it on other slides. In Europe, we had started some programs across Europe and in the nations, for instance, in Germany, in Finland, in Sweden, in France, UK, Italy. So we really have a bunch of research opportunities, and as researchers, we are very happy about that. But on the other hand, that also leads a bit to fragmentation. And then North America, South America, they started programs. Asia, in China, Korea, Japan, India, they had all their programs started. And then we had new associations formed towards 6G. We will hear something from 6G IA later. We have Next G Alliance, and then also the Korean and Japanese activities. And other existing organizations, they published their position papers, transitioning from 5G to 6G. So that's all existing. And, but that a lot of this happened basically independently because we've been isolated, all of us. And if we look at the, let's say, the target to start standardization for 6G in about 2 years and to roll it out in 7 to 8 years, there is not much time really for consensus building. And consensus is very important because it's a large ecosystem, and the players in the field really have to feel that certain solutions are viable, sustainable, and make sense for business cases. And what we see now that the technology components might be identified. To which extent they will go in, we will see, and that's really to be done in near future. And therefore, international collaboration is very, very important. And to give you some examples, I'm from Europe, so I will more focus on the European approach. In the EU, we have research. We have these smart networks and services call or programs set up, and recently 27 new projects were selected for funding, and that's the first phase, what we see here in that picture. And it will be followed by a second and a third phase, so well going into 6G. And to give you a bit more context, I mean, in that program, we had, I mean, different streams. One was really going continuously towards 5G Advanced. Then another stream, it's really more revolutionary technologies towards 6G. And then complementing this, really building up, I mean, larger infrastructures to test things and really to get researchers and companies together in Europe, and also companies and parties from around the globe join some of these projects. And you see the names here. I mean, on the slide you find the web address where you can get further information about these programs and what's in the projects themselves, which really cover a wide range of activities. In Germany, we started a so-called 6G platform, And basically, we identified and formed 4 research clusters across Germany. So one is 6G RIC, which is led by my dear colleague, Professor Slavomir Stanczak in Berlin. Then we have the 6G, the 6GEM, 6G Live, and the Open 6G Hub. Everything is coordinated by Hans Schotten, probably very well known to most of you. And these programs are funded over 4 years, and basically it's targeted towards academia, which is really funded in these programs, and then we have associated collaboration with industry partners. And to give you an idea what we do in the project 6G RIC, I mean, we have different technology innovation areas. One of it, you will not be surprised, is sub-terahertz communication. Another one is intelligent radio environments. So these are these reconfigurable intelligent surfaces are involved there. Then network as a sensor. Then autonomous convergent networks is another area, post-quantum security, and 6G connectivity. And I mean, that's a whole bunch. We have about 70 million euros funding for 4 years. We have 20 academic partners and more than 60 associated partners to really keep close connection. And if you really want to see what the outcome is, I mean, on all the main conferences, we have a booth, and then the partners will show the latest achievements in demos, what is already possible and can be prototyped. And this, just to give you an idea, to keep close connection and to make this 6G work relevant, we have associated industry partners. Some of them you see on the left-hand side, and then we also keep close interaction with standardization bodies and other industry fora, really to keep in contact so that this research, which is just very timely, is really having a chance to lead, to go into the standard when it's then to be defined. And I mean, we've seen many of these standardization timelines already. Here is one which is more backwards looking, because we started release 15 as the first release for 5G, and now we are in the 4th release, almost finished, and then we will continue. And then in 25, 26, we will start the specification for 6G. And why I'm showing this picture is that in standardization, we have like standard releases, like software releases. So one is building on the ones before, and that has a good reason, so we can rely on sustainability on what we've built before and decided before. And sometimes, or in many cases, you have to find the right point to enter new solutions, new technologies into this track. And one important part, and Jehun already introduced, was the topic of full duplex, where we worked with other interested proponents on that topic. Since release 15 and 16, we tried to bring the urgency and the need that this should be studied. Finally, in release 18, we were happy, together with others, partners, to achieve that a study item was basically started. And in release 19, we will then look forward to really go into the normative phase and make a full duplex. at least in the form of subband full duplex, something which is should be a part of 5G advanced. Full duplex, I mean, is really the opportunity to transmit and receive at the same time, not necessarily at the same frequency resource. And I mean, it's a big enabler for many things. I mean, we had the big promise in 5G that TDD will solve everything and will bring flexibility to us in allocating uplink, downlink, capacity flexibly. In reality, because we run TDD without filters between operators and bands, we had to, let's say, configure all networks to the same slot structure from the beginning. And so there is still something to do in order to get this flexibility. So full duplex could be an enabler in that sense. And another part, and that's obviously, is integrated communication and sensing. That means if we can listen while we talk, so basically sense the environment at the same time when we transmit, that is a big enabler. And therefore, full duplex, in the way we will start to standardize it, will be probably something which has larger impact into 5G advanced and 6G. And you see here different members in that interest group, mainly from Asia. And these are industry players and also academic partners from Korea, from India, from Europe. And because this topic really was a joint interest of us, we really worked together really to work only with proponents parallel to what happened in standards to really prepare a common understanding what's doable and what is also doable in the way of bringing it into the larger audience for consensus to get into the standard. So this is one example where over a long period of time, I think in total 5 or 6 years, we worked together and in the end we achieved that. And I think none of the partners alone would have achieved that because that needs a concerted effort. So collaboration is key. And how did we do that? We had these meetings and then we did a lot of promotion activities at all these conferences. We had topic workshops, we had panels on full duplex, so we extended the scope to other interested players in that field, and we had publications, joint publications, individual publications to really create visibility for this topic. So this was one of the collaboration examples in the general sense towards 5G and 5G advanced. And the other area where we worked a lot in is millimeter wave in the past and now together with LG Electronics on sub-terahertz communication. I'm a big proponent of millimeter wave communication for many years, and in that area we worked together with partners in Europe. We had joint calls with Japan, we had joint calls with Korea on that topic from the EU side, and these are topics which were driven, which went into the standard. I mean, the market acceptance and success is still on the way. Let's see. Still, we believe that beyond 28 or 60 gigahertz, there's more to come. We did a lot of measurements in that area, so we are happy to work with a partner who has interest in that field from an industry perspective. And how did we approach that? Maybe I cover more the technical field. We really tried to approach, I mean, beamforming in that field because we need very sharp beams with passive beamformers there is an element which is called a Rotman lens, which allows you to go into one input, and then you have different phase on different outputs, and the different phases then allow you to have a phase shift and a beam forming then over the air. And I mean, the beam can then be enhanced, because if you do that one-dimensional, then it's a fan beam, and in order to collimate this in the elevation, you use like a dielectric lens. It looks very similar to what Nokia had for 28 gigahertz when it was prototyping for 5G. But I mean, at this frequency, everything is much smaller. And after we had a large discrete building in the first phase, we now have really an integrated version. You've seen it in the video Jehoon showed before. And the model and this beamforming can be done at the transmitter and the receiver. And our initial tests were then done indoors, because indoors has the big advantage. You have everything under control. You can really see your EVM, what's done, and then you can optimize the system, and directly from being indoors you can calculate what do you need to extend from 9 meters to 300 meters to 500 meters. All the parameters can be derived, optimized upfront, and then you go outdoors and then you can prove that it also works outdoors. And another thing which is close to my heart is that this sub-terahertz communication works very similar to everything else. You have very good reflection on the walls, so indirect multipass reflection in the room is no problem, as long as you can steer your beam into all directions. And that's basically, besides distance to bridge, another topic which we will continue to follow on, really to allow to go from one-dimensional beamforming into multi-dimensional beamforming, and this opens the door to either MIMO to a single user, multi-user MIMO, or you can really do more complex beamforming to match the channel. And that's basically, that's what we are targeting in the ongoing project, to really extend step by step also on sub-terahertz communication. To summarize, international collaborations are the key for the success of 6G, and I think there is an urgent need to align the ongoing 6G activities regionally and globally. I mean, one big means are events like this, where people really get in touch with each other. And then what's really important is to have a use case analysis through industry platforms. That's done, that's on the way. And then also, let's say, unbiased technology exploration between academia and industry research. We see a trend. There are certain industry standardization groups formed in ETRI, for instance, towards sub-terahertz, to reconfigurable intelligent surfaces, and ISAC. So these are similar, like these FDR-IG group, proponent groups, which can really achieve consensus on what is doable early before being exposed to all the opponents in the field who don't see any benefit in these technology components. Proof of concept demonstrations are very important. We've seen that. And then tighter interaction with the vertical players. Co-creation, again, I'm advocating this. The vertical players themselves are not in standards or in very few numbers, but co-creation is important to really see what they really need, and they learn what is really available. And then I think we should consider a more forward-enabling standardization process. I mean, we heard a lot of views, have your feet on the ground, make money with what you have in your product. That's right. Still, if your product is maybe not an enabler for a new business case, you tend to basically prevent the introduction of that. Therefore, we have to be more open-minded and to rethink how we also cater for the long-tail market and the long-tail opportunities for 6G. That summarizes my talk. Thank you very much.